Okay, it's recording now.
Okay, let's go.
Okay, so did you understand how to derive sine 60 degrees? Ayush, mate,
Hello, hello.
hello.
Yeah,
Did you understand how to derive sine 60 degrees?
yeah.
So from there on, deriving sine 30 degrees would be very easy because what you're doing is you're basically flipping this triangle to this triangle to, oh, okay. So you're basically flipping this triangle to this side so that theta becomes 30 degrees. And it's pretty much the same triangle, but yeah. Okay, so our next derivation, it's even easier. But it's sine and cosine 45 degrees. How do you get that? So I'm going to draw, here is it, here and here. Okay, so this is 90 degrees and this is 45 degrees. Your theta is 45 degrees, right?
Okay.
Okay, so if this is 90 degrees and this is 45 degrees, what is the value of this angle?
Which angle?
This one.
It's gonna be like, wait, 90 plus. It's 45. Come on, bro.
Yeah, it's 45 as well. So can you identify? Okay, so we now know that two angles of this triangle are the same. So can you identify what type of triangle this is?
This is isosceles triangle.
Okay, so you know what properties isosceles triangles have?
Uh, Two sides are same.
Yeah,
But wait.
so
My point is, why are we even doing this?
because you want to make maths intuitive and sensible, these formulas don't drop from the sky on your head. These formulas can be logically derived.
Okay. Don't get personal. Okay. So my point is, so my topic is ratios and identity,
Yeah,
right?
so this is a part of your ratios. Um,
Ratio of what? But we are proving the values of sine theta. How is it ratios?
I mean, common values are part of ratios, right? Yeah. So this investigation, which starts which nobody reads, but it's basically starts your section. It's basically doing the same thing. I just read over it.
Okay. But like, so first in my presentation, I will explain what.
You will explain that maths is only fun when it's intuitive. Sine 60 degrees formula doesn't fall from the sky, and then you will show all this. Yeah. Okay, so let's get on about it. So,
Okay.
what properties does an isosceles triangle have?
Two sides are equal.
Okay, so which sides are equal over here? So let's mark this. This is A, this is B, and this is C. So which sides are equal?
AB and BC.
Yeah, right. Okay, so now I'm going to turn on annotation mode. Okay, so now what we are going to do is we're going to take AB as X and BC as X as well. Then, uh, because they are the same, so we can take both of them as X, right? Am I right?
Wait, I'm
Ayush, am I
thinking.
right?
I'm thinking still. Wait.
You just,
So your question is that, yeah, okay, yeah, got it.
okay, so what is the value of AC now?
The value of AC will be x square minus x square 2x root 2x.
Yeah, so AC would be root 2x. Okay,
Okay.
so what is what is sine theta in this triangle, in this triangle.
Which one? Left one or right one?
Right one. I just made a pointer over there as well.
Okay. So sine theta will be x over root 2x. Oh, 1 over root 2.
Yeah, so it would be x by root 2x, and this would cancel out, and this is 1 by root 2. And what would be cos theta?
Cos theta will be, oh, x over root 1 over root 2.
Yeah, it would be 1 over root 2, and theta is
Yeah.
45 degrees over here. So we have just
Yo,
proved from scratch that this sine 45 degrees is equals to 1 by root 2 and cos 45 degrees is equals to 1 by root 2. Clear all drawings? Okay, I'm going
everything is
to,
clear now.
okay, so I'm going to put this thing into the slides now. So, and all the explanation, Ayush,
Hey,
you know, I have a bad habit that I tend to like put too many things into the slide, and I'm trying not to do that. So I'm putting the explanation I gave you inside the speaker notes.
what is speaker notes?
This thing over here, this thing, which
Where I
which
can't
does
see
not
up.
get displayed in a presentation.
Where is your speaker note? I can't see.
Wait, you see the YouTube link here.
Yeah, yeah, yeah.
This is a part of speaker notes.
Wow.
So speaker notes are meant to like help the speaker because like uh, while making a presentation, one of your like in order to make a good presentation, you have less on the slide and you explain more. You don't, and I don't follow that a lot, but I'm trying to help you follow that.
Okay.
Okay,
So
so
where are we starting from?
derivation, and then I'm going to crop, remove background. Jeez, mark areas to keep. Ayush, this is better than
Uh,
Photoshop.
is that?
Just kidding. Okay, so you have to cover like some identities next, identities, right? Like compound angle identity.
Mm-hmm.
Fuck this, I'm like, I'm closing to Telegram now.
Bro, it's recording.
Never mind.
अरे बंद करो ये दिख नहीं पड़ रहा दिख नहीं रहा Aaron,
Boy, yeah.
क्या कर रहा है ये? What are you doing, bro?
I'm removing the white background so that I can fit more stuff inside. Okay,
Oh,
changes. Okay, it didn't really work out, so we are going to use I'm going to make animations over here after this presentation and after we plan everything out. So I'm
okay.
just going to paste the pictures on, and um, the animations will help you, which I will
Okay.
do later. Control C, Control V. Wait, where is 60 degrees over here? Okay, MS Paint is over here. Okay, so let me see your book. Okay, I think I covered this, and did it get deleted or not? Let me check.
Please not.
Okay, I actually rewrote it already. So,
Ah,
okay, so I'm going to So I'm going to tell you how to present this now. So like view.
Wait, so how many slides are you gonna send me?
I think that it's going to be maximum like 5, 6. Like there are a ton of slides about on other topics over here, but I'm going to take them out
Okay.
because yeah, we are going to do just unless you're okay, we in case you have to send a presentation tomorrow, that is.
Oh yeah, I have to send it tomorrow.
Okay, okay. So I'm going to like explain the slide now. So you
Okay.
just listen and yeah, uh, and tell me like if I need to cover anything more.
Okay.
Okay.
Let's
So,
go.
huh? So over here
Let's
we are
go.
going to cover trigonometric functions and how each of them are related. So this is a triangle over here which we are going to use as a model. And okay, let's turn on annotating mode. Now sine sine theta over here is okay. So many people use SOHCAHTOA in order to remember. That is sine is uh, op this is opposite of theta by hypotenuse and cosine is I myself don't use this, but you could use this in order to remember stuff.
Mm-hmm.
So this is I don't exactly know how it works, but yeah, cosine is base over hypotenuse and a tangent is opposite over by base.
But how does this SOHCAHTOA work?
I'm actually going to look it up myself because yeah, all other students use it, but I use a different mnemonic.
No, that's Indian, right?
What?
I use an Indian thing.
No, no. I myself do like A, B, C, and I just remembered AB by BC. AB by BC is tan theta, and uh, A, AB by AC is sine theta. I just remembered like that. It's not particularly Indian, but yeah.
Oh, mine
And
is like Indian.
huh?
Mine is fully, utterly Indian.
How do you do it?
Mine is like, sine theta is P. अरे बस चुप रहोगे आप लोग? I have to show it to you in a table.
You have the annotate option over here, so you can click on annotate and draw on my screen.
Can I?
Yeah, like
Now?
send me a screenshot on Telegram. I'll tell you where the option is.
When?
Now,
How? I don't have the slide. I don't have anything to write.
screenshot. Send me a screenshot of your screen, and I'll tell you where the how to draw on my screen. I mean,
Okay.
do you
Okay.
remember how to request a remote control?
Oh, yeah, I know. Wait.
Click on that spot. Don't request remote control. There's an annotate option near as well.
Ah, gotcha.
Okay, you can use that to draw and explain.
So annotate. Where's my pen? I can't write. I can't do anything.
Rip. Okay, without wasting.
Oh, gotcha.
Okay, okay, then. Uh, proceed quickly, please.
Sure,
Yeah, yeah,
sure.
yeah. I can see.
You can?
Yeah, I can see. It's a green line. And keep drawing.
It's not working now.
Oh boy. Okay, then I'm going to wait. Yeah, it's continuing to work.
Yeah, it is now. Why can't I type? Okay, this is P, okay?
You haven't drawn the full triangle yet.
No, I'm not showing you triangle, I'm showing you Indian way. Wait. What? Okay, bro, it's so hard to type here. Let me explain you now.
Okay.
Hello.
Yeah, I'm hearing.
Are you? Okay.
Did you write E in Russian over there?
Okay, so this is P, B, P. This is H, and B. Okay, this is B.
H, and B.
Yeah. Oh, good job, man. Good job.
What?
Nothing.
H, and
B.
B.
Okay. Now
Okay.
here,
Oh, so this is base over hypotenuse, and this is what is P?
perpendicular.
Oh, so perpendicular is this thing, right?
P.
This thing is in our given triangle over here. It's BC, right?
BC. Yeah.
Okay. Okay, I get. Okay, I get. I think I get it now. Oh.
Yo. Let's go now.
Okay. Okay. Let's continue now. Oh,
Yeah.
I don't think there's anything particularly like. Yeah, I mean, people have different ways of remembering. It's not that unique to
Yeah.
you. Okay, so you can use whatever method you want to remember. I included Sokatua because that's what people like over here and understand. But I myself don't use that a lot. Or so, but if you are teaching in Sokatua, maybe like useful. So.
Bro, I think let's first search about Sokatua thing.
Wait. I'm not. I'm searching that on my phone right now. And
Yo.
uh, did you understand the next reciprocal functions?
Yeah.
So okay. So reciprocal functions. You can see this is P by H. So H by P would be the reciprocal function of sine theta. And yeah, uh, and then this is also important. Tan theta is equal to sine theta by cos theta. Other
Okay.
than other than that, we have cofactor functions. And pi by 2 is basically 90 degrees, and this makes sense because, like, if you flip this triangle around, like, if this is theta, right,
Yeah.
and this is 90 degrees, then this
Okay.
angle is going to be 90 minus theta, and 90 and pi by 2 are the same thing, we know, right?
Yeah.
So what is sine theta over here in this triangle? What is sine theta?
BC over P over H.
Yeah, P by H. Okay, so now what we are going to basically do, we are going to take the same triangle, but we are going to put this on the bottom. So this is C, this is A, this is B, and
Roll
then
over.
Ayush.
Uh-huh.
Okay, so this is 90 minus theta, and this was theta, and this was 90 degrees. Now, in terms of this triangle, tell me what is cosine 90 minus theta?
Sine theta.
Huh?
Sine
Okay,
theta.
so okay, I'm going to label it as well. BC was P, and AB is B, and AC was H. Okay, now you looks a bit messy here, but I hope you follow me.
Yeah.
What is cosine theta? Cosine, not theta. What is cosine if this is your this is your angle?
Which is my angle?
This thing on your left hand corner is your angle.
90 minus theta.
Yeah, but forget the value of your angle for a moment, and let's suppose like x is equals to 90 minus theta. Just let's just suppose let's forget this for now. And okay, what is cosine x?
P over H.
Yeah, this is p over h, and and I told you to forget this. Now just let's remember it back now. So
Okay.
cosine x, this was cosine x value, and we did a little substitution. I did a bit of substitution to help you understand. Uh, Now x was, we are going to substitute it back. So x is pi by 2 minus theta, and from this was the same triangle, so this was sine theta, and hence we have shown that these two things are the same. Did you follow me?
Huh?
Did you follow me?
No.
uh,
Oh. Oh, yeah. Now it makes sense. Now it makes sense. I got it. I got it.
okay, nice. Okay, so this and I showed you this for sine theta and cos pi is equal to cos pi by 2 minus theta, but you can similarly prove it for, wait, what the,
Bro, I'm not gonna say what the fuck at all.
Uh, and I'm not presenting to your class. That's my benefit.
Okay.
Okay, so um, in order to understand the wait, so sine square theta plus cos square theta is equals to 1. This is basically Pythagoras theorem, but given to you in a different way. For this, we may not use our triangle, but our unit circle.
Mm-hmm.
So let's draw a little shit over here, and um,
Don't draw shit, bro. Please don't draw that.
this is our little unit circle. And what are you drawing? Are you actually drawing a shit? Are you drawing an actual ship?
No, no, shit. Oh. Okay, I got you. Let's go.
Okay, so this is our unit circle, and we are going to label this A, B, C. And the feature of our unit circle is its radius is 1. And if its radius is 1, it means the hypotenuse is also 1, right? This
Yeah.
hypotenuse is 1. That's how a unit circle works. Its hypotenuse is 1, always.
Okay.
And then you find the corresponding angles. Um, I prefer using graphs to unit circles, but this is very widely used. Okay, so let's restate the Pythagorean theorem in terms of side lengths. So can you tell me the
Okay.
Pythagorean theorem?
Yeah. Hypotenuse square is equal to base square plus perpendicular square.
Yeah, in terms of AC.
So AC square is equal to AB square plus BC square.
AC square equals to AB
AB
square
square plus BC square.
plus BC square. Now I told you the hypotenuse is always 1 in a unit circle. Because this is a circle, and hypotenuse is basically your radius in a unit circle. So this is going to be 1 squared, and 1 squared is 1. So AC square is 1. Now what is AB? Okay, so this is our theta. Now using using all the that we learned with respect to a triangle in the previous I'm just going to do it myself, and I hope you follow. So the sine theta is equals to AB by AC, right?
Uh-huh.
And AC is 1 because it's a unit circle. It's only 1 unit, so and this thing is equals to sine theta, right?
Yeah.
So we can so AC is equals to 1. So this is just 1. So AB is equals to sine theta in this unit circle. So AB square, if AB is sine theta, then AB square is sine square theta, right?
Yeah.
So this is sine square theta. Okay, so now let's move on to, wait, I'll rub this over. Um, okay, so our cosine theta,
और भाई आर्यन मैं इतना लिखूंगा कैसे? मैं वो तो लिखने की आदत ही नहीं है इससे.
लिख मत, explain करना तुझे. Slide के you don't write in order to make a good presentation, and I learned it from other people, more experienced people than me. I'm not experienced at this at all, but that's what I heard. You don't write a lot in slides.
Wait,
You
bro,
have to.
your voice. I just lost your voice. Say that again. I just lost your voice when you said I didn't learn anything from experienced people.
Okay, I didn't. I learned this from other experienced people. I don't have a lot of experience myself, but in order to make a
Okay.
good slideshow and good presentation, you don't have a lot of stuff on the screen. You're supposed to say that stuff and explain that. And by explaining that, you are showing that you're not like chafing it, sticking, copy pasting random shit onto your presentation. You actually understand the stuff and you know how to explain it. That's what you're demonstrating to them.
So I'm not supposed to draw this unit circle thing.
Uh, this won't be already in the slide, but if you need it for explanation, then you do it.
Or should I or not?
I think you're making a video, right?
Yeah.
So you need a unit circle for video. So you can just include a unit circle, but don't include any explanation. Explanation would be while presenting.
Oh, so I should just add a unit circle, right?
Yeah, that's it.
Okay.
So
But
BC,
still, How
Huh?
I have to explain this AC square is equal to AB
Wait,
square plus
let me
BC square.
continue this. Like this is too much interruption. Oh, so BC by AC, we learned that this would be cosine theta, right? And then AC is equals to 1. So we can just this is 1, so it doesn't matter. BC is equals to cosine theta. So this would be cosine square theta. So it turns out this Pythagorean identity is nothing but our old Pythagoras theorem, which we have been learning since primary school, basically. Okay, now you continue what you were saying before. Ayush? Can you hear me? Can you hear me? Fucking hell. Am I being heard?
Yeah.
Okay, so what were you saying before that? Like, I just wanted to
Yeah,
complete explaining that.
I got it. So I was saying, if I draw the unit circle,
Yeah.
but still I have to explain that AB square is equal to BC square plus this or that stuff like that. I can't, right. If I just say that thirdly, they won't understand that.
If you just say what?
If I just say it like thoroughly without even explaining it, but like without annotating it, they won't understand that.
By annotating it, what you're basically doing is you're showing them that you are understanding this and you're not like copy pasting stuff.
Okay, I will annotate then.
So next, moving onwards, from which we just showed from scratch how sine square theta plus cosine square theta is equals to 1. So next over, uh, do you know how to prove this?
Yeah, you told me.
Huh? No,
Yeah,
this one,
yeah,
tan square theta plus 1 is equal to secant square theta.
yeah, I know.
Okay, but yeah, you explained that on your presentation.
Yeah,
Okay, so next, do you know how to derive this one?
what?
Cot square theta plus 1 is equal to cosecant square theta.
Wait. What? Yeah, it's the same thing.
Um, uh, Try it out.
Yeah, it's gonna be cos square theta over sine square theta, then sine square theta will take
So cot
LCM.
square theta plus 1 equals to cosine square theta by sine square theta plus 1, then cosine square theta plus sine square theta by sine square theta. Then these cosine square theta and plus sine square theta, this we recognize it's 1. So this would be 1 sine square by theta. And then you can then remember reciprocal functions. Sine theta is equal to 1 by cosecant theta. So we can also write this as cosecant square theta. Okay, we followed this slide.
Yeah.
Okay, now let's see. Let me check what we have next. What the hell? Okay, this was basically derivation. I was trying to get the derivation of sine. This is given on I've copied the diagram from your book. Really, this is the same diagram which is given on your book. This is for the derivation of sine a plus b, the compound angle formula. I mean, I'm a bit lazy to go over that, so I'm going. And derivation is not 100% needed, but we are just trying to show that these formulae don't drop from sky. But we'll go over that later. Okay, this is the unit circle. So using a unit circle. Um, so like basically what is given over here is sine theta values. This goes from 1 to 0. At the middle, it's always like 1 by root 2. And if you want to remember it, like you can give your audience a tip to remember easily. It first it's at 0 by root 2. You can also write 0 like that. Then it's root 1 by root 2. Then 1 by root 2 is the same as root 2. No, not root 1 by root 2. It's this is like a very easy mnemonic, like a memory aid. So then it goes to root 2 over 2, root 3 over 2, and it's over here it goes to root 3 over 2, and then 1 is the same as root 4 over 2. So
Okay.
like this makes it very easy to remember, so you can recommend your audience to learn like that.
Mm-hmm.
Then I put some animations, but I low-key forgot. Okay, so this thing, um, this is basically this, this is not an incomplete slide. You have I purposely left these blank spaces, and this is for you for us to cover while doing the presentation. So
Mm-hmm.
okay, so annotate black. Okay, so all this stuff here, this is the only thing you need to like um I showed you how to derive sine theta,
Mm-hmm.
sine 30 degrees and sine 60 degrees and sine 45 degrees, and you can get cos theta from the same triangle, but you don't derive every time. So like after doing a bit of trigonometry, you kind of remember them, just like for doing addition and subtraction, you stop using your hand and you stop counting on your fingers. You know it already, just like that.
Mm-hmm.
So so what we are going to do here, we know. Let's suppose you only know this stuff, and we are going to use other stuff we know in order to fill this table up. And you are the one presenting, so I'm telling you, this is something you are supposed to do while doing the presentation. And so, and to explain,
Why?
huh?
Okay, okay.
This for me, I genuinely think that your presentation would be better like this. So,
Okay.
so tan theta is equals to sine theta by cosine theta. We know this identity, and now we are going to basically apply that here. So 0 by 1 is
Okay.
0, 1 by 1 by 2 by root 3 over 2 is 1 by root 3, and then 1 by root 2, 1 by root 2. At this point, this is the same. And over here, root 3 by 2, 1 by 2, this would be like root 3. So what you're doing, okay, so now it's 1 over 0. So this thing, because your cosine theta is 0 at that point, tan 90 degrees explodes to infinity there.
Uh-huh.
Um, then you know another identity cot. So the point of this
Cos theta
exercise,
is,
the point of your exercise is you're teaching your audience how to apply the trigonometric identities as well,
yeah.
along with common angle values.
Yeah. But I also want to do for 110 degree, 135 degree.
I'll cover that separately.
Okay.
Okay, so yeah, I won't do secant theta, cosec theta now because I've already covered reciprocal function.
Uh-huh.
So cot theta is equal to 1 by tan theta. And at 0
Uh,
degrees, tan tan theta is 0, and when you have a reciprocal L as 0, cot theta is going to explode to infinity.
Mm-hmm.
And 1 by root 2, reciprocal is root 3, and then reciprocal is of 1 is 1. This is 1 by root 3, and 1 by infinity is basically 0.
Yeah.
So right there, that's how we only knew what was sine theta and cosine theta over these values, and from there we gained information about other values. Now
Same with
next,
same we can do with sine theta and cosine theta, right?
um, w- same like what are you already given to do the same?
Like we have sine theta and cos theta, so for sec theta and cosec theta, we can use that formula.
Which formula?
Like for cosec theta is 1 over cos theta, and
Yeah,
cosec
yeah,
theta
yeah,
is 1 over sine theta.
exactly. So this is now this is also covered by oh, I'm really clumsy with okay, I got it. So this is also going to be covered by, as a reciprocal function of cosine theta is 1 by cos theta, and uh, cosec theta is 1 by sine theta. So we can repeat the same procedure in that case. And then
Yeah.
next up, sine 120 degrees. You can use the unit circle or you can use the graph. Graph is my way of remembering.
Okay.
I was trying to learn how to use the unit circle in order to teach better, but I don't. I want to explain in terms of graph. So sine theta's maximum value is 90 degrees. So it's zero. So it starts at 0. Over here it's 90 degrees, and at 1 it gets to its maximum. And after maximum, it starts falling down. And that also takes 90 more degrees to do. So it's 180 degrees. And then across this line, this is symmetrical. So 90 minus 30 equals to 90 plus 30, because like it's like if you go, if how much ever you go from here and how much ever you go from here, you'll end up in the same space in the same y value. So sine 60 degrees equals to sine 120 degrees, and sine 45 degrees would be 135, and 30 would be 150, and 0 would be 180. So over here it
Oh,
returns to 0.
yeah.
I'm going to make it clear all this mess. We covered this, and
So,
covered this, and we're
how do you
covering
clear
this
all the
again.
mess in one go?
What?
How do you clear all the mess in
Uh,
one go?
Click on clear and click on clear all drawings.
Where is that option?
Can you not see?
No, I
I think this
can't.
is only for, I think only there's a host can see this.
Okay.
Okay, so using this property, we can fill out. This is root 3 by 2. This is 1 by root 2. And if you want, you can write 1 by root 2 as uh, root 2 over 2 by multiplying in root 2 from both the numerator and denominator. The I think it's helpful to remember because one is basically root. I already explained this. This is 0 by 2. This is root 1 by 2. Root 1 is the same as 1. And this will be, I showed you, this would be root 2 by 2. This would be root 3 by 2, and 4 and 1. This is root 4 by 2. Root 4 is 2. 2 over 2 is 1. So this is like a very nice way of remembering in this stuff.
What are you doing? What are you doing?
I'm uh, I'm basically giving you a mnemonic. It's like a hint to remember.
Okay. Oh,
So, so in order to remember, uh, you you can also like write all of these in terms of like denominator 2. So this is 0 by 2. This is this is 1 by 2, and 1 by root 2 can also be written as root 2 over 2, and then this is root 3 over 2, and this is 2 by 2, and 1 by 2 you can also write as root 1 by 2, and 2 you can write as root 4 by 2, and from there it starts falling back.
uh-huh.
So I'm only telling this so that you can so that it is easier for you to remember,
Yeah.
because like everything is in root, and the denominator is all the denominators are 2, so it's easier to remember in this form.
Yeah.
Now let's see what happens to a cosine graph. uh, Cosine. Oh, okay. So cosine theta. So it starts at 1 and then goes to 90 degrees. And from 90 degrees, it starts falling below x-axis. So it basically becomes negative from that point. This is 90 degrees. You can remember which quadrant it is positive in and which quadrant it is negative in with this method as well. And from over here it reaches a minimum of -1 at 180 degrees. So this is like the critical points you have to remember, but rest of all you can deduce.
Yeah.
Then it climbs back up, and climbing back up also takes 90 more degrees. So this is 270 degrees, and at 270 degrees it is 0.
Okay.
And then 90 more degrees, and it goes back to its original position, 360 degrees. If we are using the unit circle, uh, unit circle, uh, going 360 degrees would mean that uh, you have traveled all 360 degrees, and you're going to basically repeat again. Yeah. So how will this help us complete our table? Let's see. So over here and over here, this thing is basically getting like this thing is basically symmetrical, and but this part is negative and this part is positive. So like if cosine 90 minus theta equals to negative cosine 90 plus theta, we can tell that from the graph. Do you follow?
Yeah.
Yeah,
But I'm
because it
still confused how to find by using the unit circle. What is that blue thing represent? The rotation?
okay. In order to do that, I'm going to go back because I don't myself like I like using the graph instead. But let me try if I can explain it properly with the unit circle. Um, Wait, go back. Where's the previous slide option? Okay, got it. The unit circle. Okay, it is showing up. It was the same slide, but we had done like I'd put an animation over there. Okay, we got there. Annotate. Okay, so this corresponds to right angle triangles, and so according to the unit circle, this thing, this right angle triangle, uh, it starts at You still have to remember what is it is at 0, what it is at 90, what it is at 180, 270, and 0, 360 is basically repeating from that point. So, okay, is this the sine value or cosine value? Okay, I see now. So it's basically giving me cosine value. This unit circle is giving me cosine values first and then sine values. Look at the number on the right side, the sine values 0, 1 by 2, root 2 by 2, root 3 by 2, 1. Razor. Okay, so cosine begins from 0, it goes to 1, and then goes back to 0. So if you draw a right angle triangle with theta is equals to 30 degrees, and you you want to know like in the second quadrant how that would behave. So since this is 0 and this is 0, right? Yeah. Ayush,
Yeah. I'm saying.
Ayush,
Yeah.
I think I can hear you, but it's very faint. Um,
Hello.
it's very faint. Check micro.
Hello.
Oh boy.
Hello.
Okay, wait.
Can you hear me now?
Ayush,
Hello. Hello.
yeah, I'm able to hear you, but for some reason it's getting like a very faint, like your voice is not loud as it was.
Hello.
I do hear you.
Okay.
I do hear you. Do you hear me though?
Yes.
Okay, no problem then. I
Yeah.
was just checking on.
Okay.
So the next up, uh, yeah, from here we are going from 0 to 1, and over here also we are going from 0 to 1. So you can actually draw a 30 degrees triangle, 30 degrees triangle over here as well, and this would be the same thing over here. So like this, you have shown that now this 30 degree, you can also draw 30 degrees triangle here, and this would be the same thing over here. So by doing this, uh, so by doing this, you have basically shown that so 180 minus 30 would be 150 degrees, right? This is 180 degrees and minus 30 degrees, and this is
Uh-huh.
30 degrees. You have shown that sine theta equals to sine 180 minus theta. Yeah, that's right. Okay, so you can yeah, you have to practice with the unit circle to understand that. And I'm already used to another method, but I guess for teaching purposes, you have to cover the unit circle too, because a lot of people, uh, because everyone is taught unit circle firsthand.
Yeah.
Now let's go to cosine theta. Cosine theta at first it is 1.
Aryan,
Yeah.
can we start again in 15 minutes? My mother is calling for food.
Okay, I'll pause this. I'll okay, I'll actually shut it shut it down and we'll restart after a few minutes. We are recording all through.
Okay.
Okay, that's that's it for this session, and
Yeah.
we are going to restart recording afterwards. We are stopping recording now.